Okay, welcome to my channel. So here we have a problem of a sphere which is tied to a rope at the bottom of a lake. And of course, let's assume that this lake is just pure water, so that the density of this one is just the density of water, which is 1000 kilogram per cubic meter. So this is now the lake. It's merged it's tied to a rope. This is now the rope. It's quite thick, but let's assume that that's a rope. Which is the mass is 8,500, and the radius of the sphere is about 2 meters. Okay, so the question now is that will the object pull up the rope? Here it's actually um, I don't know the right word for this one, because I just made this problem up. Actually, most of the problems in these channels I just actually made them up. Okay, so meaning that will it be able to stretch or to pull the rope up? Okay, meaning that that would give us, if this object will pull the rope up, okay, um how much tension will it cost to the rope? First, let's ask, why will the object be able to pull this up? And in fact, as you can see, this problem is the reverse of tying an object, a spherical object, on a ceiling in air. Okay, this object will certainly, because of the weight of the object, so there's a tension on the rope there. This is just okay, a very easy problems on tension, but this one is the reverse. And why is this? Because if the buoyant force, in order for this, for the object to pull up, because that's the first question, the buoyant force, okay, let's actually draw a free body diagram. The buoyant force now, okay, I'll just write in blue. The buoyant force here and the weight of the object. Okay, I'll use a different color. Where's the violet here? Okay, there's the violet. Okay, the weight of the object. Okay, here. Now, if the buoyant force is greater than the weight of the object, without this rope, the object will accelerate upwards, just like without this rope the object will accelerate downwards, in this case here in still air. Okay, now in order for that, if fb is greater than the weight of the object, in order for it to prevent to move, that will be reciprocated by the tension on the rope. So meaning there should be a tension on the rope. Let's use a different color again. I'll just use pink. That would be, there should be a tension on the rope. We call this the tension, okay, in order to reciprocate the positive difference of the buoyant force and the weight of the object. So to answer the first question, okay, we all we have to do is that, is this is just the same as the question, is fb greater than the weight of the object? So meaning, in order to find this out, let's calculate the uh, uh, I mean, for this to be true, we know that this is equivalent to remember the condition that the density of the fluid times the submerged volume must be greater than equal to the density of the object times the volume of the object. Now, in this case, since we are assuming that the object is fully submerged in water, then that now means that the submerged volume is equal to the um, uh, of volume of the object. So when this cancels out, because they are the same, the condition is that the density of the fluid must be greater than the density of the rope. Okay, so now let's calculate now the density of the rope. Okay, sorry, not the rope, but the density of the object. So what's the density now of the object? Okay, meaning that this one is the same as the statement: the density of the fluid is greater than the density of the object. Okay, the density of the object now is equal to the mass of the object times the volume of the object, which is just, the mass is given 8,500. So this is just 8,500 kilograms over the total volume of the object, which is 4 thirds pi times that would be 2 meters cube, and this will give us, okay, 8,000, that would be 8,500 divided by 4 times pi times 2 cube divided by 3, close parenthesis, and that would just be 253. Okay, as you notice, this is just 253. I'll write it here. This is just equal to 253.65 kilograms per cubic meter, which is less than 1,000 kilo, because our fluid here is just the water. It's just the lake, which is assuming to be a water, approximately close to this one. So the answer to this is yes. Okay, because it will create a force. I mean, uh, the buoyant force will be greater than this, the weight of the object. Okay, the buoyant force now will be greater than the weight of the object. So, okay, that will create an imbalance. Now that imbalance will be reciprocated now by the tension. So to answer letter B, in order for this to be in static equilibrium, that means that the buoyant force minus the weight of the object, okay, minus the tension equals 0. From here, we can see that the tension is just equal to the weight of the object minus the buoyant force. Okay. Uh, okay. Sorry, it's correct. Actually, tension is downwards. Okay. Tension is downwards. So the weight of the object is just, again, 8, the mass of the object times G minus the buoyant force. What is the buoyant force? The weight of the amount of this amount of water. So meaning that is the density of water times the volume of the object times G. Okay? So this is the volume of the object is now just this. Okay? So we can now calculate this. This is just equal to what's the mass of the object? This is equal now to 8,500 times 9.8 minus, you have the density, so 1,000. Okay, 4 times, I'll just put a parenthesis here, 4 times pi times 2 cube divided by 3 times 9.8. This would give us the tension. Okay, their difference, it's so huge, so big, newtons. This is 2.45 times 10 to the 1, 2, 3, 4, 5 to the 5 newtons. Okay, actually you get a negative, but meaning that what really this one is that, uh, okay, there's a mistake in this algebra here. This is negative here, right? Because I move it to this side. So meaning that you have a negative T here, that would mean that the tension would be equal to 2.45 times 10 to the 5 newtons. Okay, whenever you have, since this is positive, it doesn't mean the tension is going up. It only means that my assumed direction is correct, because I assume the downward direction and I obtain the positive number, meaning that this is indeed the correct direction of the tension. What if I obtain a negative number? Okay, I obtain a negative number. So that would mean that the correct direction of tension is upwards. Okay, so you don't actually have to worry much about the direction of your assumed force, because that will come out in the value later. Okay, here I obtain a positive. Again, I like to repeat it. I obtain a positive force. It doesn't mean that the force is upwards. Okay, it only means that my assumed force, which is downward, based on this equation, I assume it to be downwards, then meaning my assumed direction is correct. If I obtain a negative instead, then meaning it's the opposite of my assumed. Okay, here the negative is due to the fact that I mislooked this one here, this negative. Okay, I always commit these mistakes. Okay, so there should be a negative here. When you multiply it by the negative, it becomes a positive. So meaning that is now the tension, knowing that is very great. It's actually even greater than the weight of the object. Okay, uh, it's because of the buoyant force is so great. Okay, because that would only mean that the mass. This is the whole object. If you weigh this whole object, okay, let's take the whole object to be in red. Okay, that one here. If you weigh this in air, and suppose that this is the equivalent water, okay, so meaning, again, if you weigh this in a weighing scale, meaning that this is much greater in this case. This is the buoyant force, the weight of the fluid displaced. This is the fluid displaced. The size of the fluid displaced is equal to the size of this object here. If you weigh that, that's the buoyant force. If you weigh this is the weight of the object. In this case, that would mean, in this our problem, since FB is greater than uh, the weight, meaning that, okay, this water would actually weigh heavier than the object itself. In fact, that's because the object has only a density of 253 kilogram per meter cube. Okay, so anyway, this sums up our problem. Thank you for watching, and if you have not subscribed yet, please subscribe, because we have more problems to solve here, and most of the problems in this channel, I actually I'm making my own problems in this channel, and not all, but in many cases, I think so far all of the things I've discussed in this channel are my own problems. Okay, um, so thank you for watching,